example of distance, rate, time problem. Okay, let's take a look at another example. It's another word problem here. The motorboat can travel on a river upstream 25 miles in the same amount of the time it takes to travel 48 miles downstream. If the speed of the river's current is 6 miles per hour, we're going to find the speed of the motorboat in still water. Can somebody tell me who's logged in online tonight the formula we have to use for this word problem? Distance, rate, time. So what's the formula?
D equals R times T.
So distance equal to rate times time. So what is it the same in this problem? Anybody can tell me what is the same for going upstream and downstream? Something is exactly the same. What is that?
The miles, 48.
No. The miles is different. One is 24 miles, the other one is 48 miles. Something else is the same. Someone else can tell me what's the same here?
The current is the same at 6 miles?
No. Well, read the first line carefully. What is the same?
The amount of time.
Yeah, it says the time. This is in the same amount of time all this happening. So the time is the same. So let's solve this for time then. If I solve t in terms of distance and rate, can somebody tell me what this time is equal to? Time is equal to what in this formula? How do you solve t in terms of distance and rate?
Rate divided by distance.
Right. V over R. Very good. So the distance that we're traveling upstream, okay, let's say this is a situation that we're going upstream. So the time would be, what would be the time going upstream in terms of D and R, anyone? The distance is given. What's the distance here going upstream?
24 miles.
24. Okay, now what would be the rate going upstream? Okay, let B equal to the rate, rate of the boat, motorboat, and what is the rate of current? Do we know that?
So the rate going upstream would be -6 miles per hour?
Well, the rate of the current is given to me. What is that? It says right here.
6 miles.
Yeah, 6, right? So what would be the rate going upstream here? Going upstream, the rate of the current would be against the rate of the boat. So
3 miles?
No, in terms of B. Anyone?
B minus 6.
Very good. It's B minus 6. That's what it is. B minus 6. See, the rate of the boat going upstream would be whatever the rate of the current is would be against the rate of the boat. So it would be B minus 6. The rate of the boat minus the rate of the current, since it works against us, that would be the rate of the motorboat going upstream. So that's the time it takes that to go upstream. Okay, now what would be the time, the same time, that is going downstream now? Okay, going downstream, what would be the distance here, first of all? Somebody tell me what's the distance going downstream. That's given to us. What is it?
48.
Right, and it's 48. Now, what would be the rate? How fast we're going downstream in terms of the rate of the current and rate of the boat? What goes here?
B plus 6.
Very good. That would be B plus 6 now. Because now going downstream, the rate of the current would help us add to the rate of the boat. When you're going downstream, the rate of the current add to rate of the boat. If you're going upstream, the rate of the current would be against the rate of the boat. So these two times must be exactly equal to each other. So we can write this that 24 over B minus 6 must be equal to 48 over B plus 6. So it's like a proportion here. So to solve for proportion, we can cross multiply. 24 times B plus 6 must be equal to 48 times B minus 6. This is how I can solve for B. I can distribute here. We get 24B plus 24B plus, we have 24 times 6 in 144. Distribute 48B minus, we have 48 times minus 6. They give you minus 288. Here I can subtract 24B from both sides of the equation. On the right hand side I get 48 minus 24. They give me 24 plus 24B. At the same time, if I add 288 to both sides of the equation, I get 288 plus 144. That gives me 432. Can somebody tell me what this B, or the rate of the boat, is in this case then?
18.
Right, divide 24 into that. That would give you 18. 18 what? Don't forget the units.
18 that's going to be miles per hour.
Very good. That would be 18 miles per hour. So that would be, find the speed of the boat. That's exactly what we found. This is another example of rate times distance. Can I see a check mark in front of your name if all can follow this as well, please? All right. Another type of problem we didn't cover last time was solving second order equation by completing the square, and that also is in the take-home test number 4. Please make sure to review all the problems that we have for take-home test number 4 to prepare for the next exam. We have there 3 different ways to solve equations. In addition to factoring, we looked at how to solve equation using completing square method, also quadratic formula, and square root property. Those are the type of problems that we have. A complete solution to take-home test number 4 is also posted in class and also in the mini sessions that we have. Review them, please, to get ready for the next exam. We're kind of getting out of time here, so if you have any questions, specific questions, I can stay up a little bit longer. If not, we can continue all these problems. I'm going to start looking at problems from sample final again on the next session. Please read the class announcement for the next online session and view all the old ones to prepare for the next exams. If any of you have any questions, you can stay up now. I'm going to stop recording at this point. If you don't, you can go ahead and click on the door out, and we'll see you all next time.